Hi, I'm Miss Hearn. Let's get started. In this video, we're going to prove the identity that the inverse cosine of x plus the inverse cosine of negative x is equal to pi. We're assuming that x is a positive angle. So I just want to remind you about the relationship between the cosine and the inverse cosine. On the left, I have a graph of cosine of x, and the cosine of x is not an invertible function. It doesn't technically have an inverse because it's not one-to-one, unless we restrict its domain just to be between 0 and pi. And so on that interval, which I've highlighted in yellow here, we do have a one-to-one function. And if you invert it, meaning take the inverse, so flip all the x's and y's, you get y equals inverse cosine of x. And that's on the right here. And you can see it's only defined to have outputs, y values, that are quadrant 1 and 2 angles. So when we take the inverse cosine of some value, it has to be a value, but first of all in the domain, so between -1 and 1. And we're going to get an angle that's between 0 and pi. So keeping that in mind, we want to show that the inverse cosine of x plus the inverse cosine of negative x is equal to pi. So remember, when we take an inverse cosine, the output is an angle. And since we're assuming x is a positive value, then out of quadrants 1 and 2, the angles that have positive cosines are in quadrant 1. So let's call this angle theta. That's equal to the inverse cosine of x. So that would mean the cosine of theta is positive x over 1. And it's in the first quadrant, so I've drawn a picture here of our angle theta, adjacent over hypotenuse x over 1. Now what we'd like to know is if that angle is theta, what can we discern about the inverse cosine of negative x from this information here about x? Well, if x is a positive value, negative x is a negative value. And that negative x is going to be associated with some unknown angle, and that angle is going to have a cosine of negative x over 1. But we know that the reference angle for that angle is going to be theta. This angle here has to be theta because this is the same size right triangle that we had up here. And we know that cosine of theta is x. So that means that this angle here must be pi minus theta. Pi, remember, is the whole half circle, semicircle. So if we take away theta from that, we get the angle that has a cosine of negative x over 1. So we just figured out that the cosine of pi minus theta is negative x, or in other words, that the inverse cosine of negative x is pi minus theta. All right, so back to the statement we're trying to prove. We need to know what the inverse cosine of x plus the inverse cosine of negative x is. Well, we just figured out that if the inverse cosine of x is theta, then the inverse cosine of negative x is pi minus theta. And theta plus pi minus theta is equal to pi, which is what we were trying to prove. I hope you found this video helpful. If you did, please remember to give it a thumbs up. Every time you like the video, that helps other students to find it.